Hello friends, welcome back to my channel, and today in this video we are going to study about testing for independent assortment of linked genes. Now, as we are learning from quite few videos that linked genes are the genes that do not obey Mendel's law of independent assortment. So they do not obey 9:3:3:1 ratio, or if we talk in terms of test cross, then we won't get 1:1:1:1 ratio because they don't behave as two separate genes, but they behave as a one single gene because they are very tightly linked. Therefore, the recombination does not happen between them. But even in linked genes, some crossing overs happen in some meiosis. Though they are linked, so the crossing over does not take place in all the meiosis, but in some meiosis, some amount of crossing over happen between them. Therefore, we get more number of non-recombinant compared to the recombinant progenies. We get both recombinant as well and non-recombinant as well, but we get more number of non-recombinant because the genes are linked, but we also get some number or amount of recombinant progenies. So this we are learning from quite few videos. Now, what if the difference in number is not that prominent? Suppose we performed any test cross and the number of progenies we obtained does not show a significant difference in their number. For example, capital A small a, capital B small b, when test crossed with small a, small b, the number of progenies obtained were 54 AABB, 56 AABB. These two are parental type. That means these are non-recombinants. And also, we obtained lesser number of recombinants, 42 and 48. But the number is not very less if we compare with 54 and 56. That means they may be in 1:1:1 ratio, or they may not be. Maybe whatever the difference we are seeing here, they are assorting independently, but still the ratio is not exactly 1:1:1:1, maybe because of chance. Or maybe they are linked, but considerable number of crossing over happened, because of which this 42 and 48, which should be actually very low, but they are quite close to the non-recombinant. So because we able to see the difference, but the difference are not very prominent. They are very slightly different from each other. So maybe they are assorting independently, but if they are assorting independently, the ratio should be exactly 1:1:1:1. But we can see the difference here. That may be due to chance, or maybe the genes are linked. If the genes are linked, then this 42 and 48, that is the recombinant number, should be quite low compared to the non-recombinant. But here the difference is not that much prominent. That means the number of recombinants are quite close to the number of non-recombinants. So we don't know whether it is independently assorting or the genes are linked. So how do we distinguish between the roles of chance and of linkage in producing deviation from the result? So let's first examine the test cross ratio in a cockroach to examine whether there is a deviation. So that means our hypothesis which we need to test is deviation is there or not. Correct? So we are hypothesized that there is a deviation. Now we are taking this y plus y, cv plus cv crossed with yy, cv, cv. This plus sign is for dominant one. This y without plus sign and cv, these are recessive characters. Y for color, giving yellow body, which is recessive, y plus giving brown body. cv, curved wings, recessive in nature. cv plus, straight wings, dominant in nature. So what we did, we took a heterozygote parent and crossed with a homozygous recessive parent. This is called test cross. When one parent is recessive and another parent is heterozygote, that is the offspring of F1 progeny. So we call it as a test cross. This is one parent. Now, the observation we obtained is this one. As you can see, this is parental genotype, 63 progenies. This is recessive parental genotype, 77 progenies. These two are the hybrids or recombinants with 28 and 32 progenies, total of 200 progenies. So first step is we have to test the ratio in each locus. We have two locus, one locus for color, another locus for the shape of the wing. So we have two locus. So first we have to test the ratio individually in both the locus. How to do that? So our first locus is color. So for the color, it is Y plus Y crossed with YY. Heterozygote crossed with homozygous recessive. Now expectation is it should be half capital Y plus Y and half small y small y. So half should be brown and half should be yellows. That means because total number of progenies are 200, so 100 should be brown and 100 should be yellows. But what is our observation? As you can see here, let's see with the brown. See the observation? This is brown body. How many progenies? 63. This is brown body. How many progenies? 28. So here it is written 63 plus 28, that is 91. Similarly, for yellow bodies, this is yellow body, 77 progeny, and this is yellow body, 32 progenies. So total of 109 yellow progenies. This is our observation. It should be 100 and 100. But what we got? 91 and 109. Now we have to apply chi-square test. The formula is chi-square equals to summation of observed minus expectation whole square divided by expectation. So for the brown progenies, observed is 91, expected is 100. Whole square divided by 100 plus, because in the formula only summation is there. So plus for yellow bodies, observed 109, expected again 100 divided by 100. So once we solve this, we'll get 1.62. Remember this, the number of chi-square test 1.62. Now we need degree of freedom. The formula for degree of freedom is n minus 1, where n is number of expected classes. So we have two phenotypes, brown and yellow. So expected classes are 2 minus 1, that will be equal to 1. So our degree of freedom is 1. Now we have to see the chart, the table for chi-square. Now our threshold is 0.05. This is our threshold. We have two directions, this one towards the left and this one towards the right. If the value of chi-square comes towards the right direction, then we will accept the hypothesis. If we get the value towards the left hand side, then we will reject the hypothesis. So our threshold is 0.05. Less than 0.05 probability we will accept, more than 0.05 probability we will reject. Now if you remember, I asked you to remember the chi-square probability number, that is 1.62. So now our degree of freedom is 1. So where you can see DF1, this first one. Now along the table come up to 0.05. What is our value? 1.62. Where you can find 1.62? For 0.05 it is 3.8. 0.1 it is 2.7. So definitely 1.62 will be somewhat here between 0.05 and 0.1. What I said, towards the left we have to reject the hypothesis. What was our hypothesis? That there is a deviation. With this hypothesis, we started that there is a deviation. But we have to reject the hypothesis. That means no deviation. So the conclusion is the genes are not deviated from 1:1 ratio. Why here 1:1 ratio? Because we are working with only one locus. When we work with two locus, in that case, we have 1:1:1:1 ratio. This is for independent assortment. This, when we work with single locus, it is law of segregation. When we work with two locus, it is law of independent assortment. When we work with one locus, it is law of segregation. Clear? So, because we have to reject the hypothesis, that is, there is a deviation, that means there is no deviation is there. So genes are not deviated from 1:1 ratio. That means genes are assorted independently. Similarly, we have to work for the second locus. The same expectation should be half and half, but the observed 95 straight wings, 105 curved wings. Again, we have to apply the formula. After solving, we'll get the result as 0.50. Now here also degree of freedom is 1 because number of expected classes 2. Curved wings and the straight wings. So 2 minus 1, 1. So again we have to see the first row of the table. Come up to 0.05, this one. The value is 3.8. 0.1, 2.7, 0.5, 0.4. So our 0.50 should be somewhere between this. So that means towards left. What we have to do if it is towards left? We have to reject the hypothesis. Hypothesis was there is a deviation. So the conclusion is no deviation, genes are assorted independently. Now next is we have to test for independent assortment ratio. Now in case of independent assortment, we work with two locus together. So these two, the parental genotype, these two, the hybrid genotype or the recombinant genotype. Expected phenotypes are written here. Now expected proportion is, as we already calculated for YY, it is half. We already calculated individually for CBCV, it is also half. Because it is independent assortment, we are taking two locus at a time. So we have to apply multiply rule for the probability. So half into half is 1/4. So for all the expected ratios or proportions are 1/4. So when it is 1/4 and total number of progenies, if you remember, it is 200. So the expected numbers will be 50-50 each. But the observed are 63, 77, 28 and 32. Now again, we'll apply the chi-square test and we'll get the result of 34.12. Now here, can you tell me what will be the degree of freedom here? N is number of expected classes. How many classes you can see here? Pause the video, think how many expected outcomes are there, and then come back to the video to see the answer. So how many phenotypes? 4 phenotypes. 1, 2, 3 and 4. So N is 4. So 4 minus 1, that is 3. So now which row we have to see? DF3, as you can see here. DF3, this we have to see. Now come up to 0.05 here, 7.8. What we obtained? 34.12. So definitely, if you see here 7.8, this is 9.3, 11.34. That means it is going towards right. So when it is going towards right, what we have to do? We have to accept the hypothesis. So what was our hypothesis? There is a deviation. We have to accept. So we will say, yes, there is a deviation from independent assortment ratio. So when there is a deviation from independent assortment ratio, that means the genes are linked. They are not assorting independently. Now one thing, we did for individual locus, which is our law of segregation. We also performed chi-square test for independent assortment, both the locus together. For segregation, we obtained the result that there is no deviation. In independent assortment, we obtained the result like there is a deviation. We are accepting this finally and we are saying that yes, the genes are linked. Then what is the need to perform law of segregation? Definitely will depend upon the result of independent assortment only, but this result depends upon the segregation. Because here it is both the locus together. For example, one is A locus, one is B locus. For segregation, we are working with locus A individually and locus B individually. But for independent assortment, we are working with locus A and B together. So that means this A and B depends upon how they are behaving when they are individual. Clear? Now, let's simplify what we learned here. Suppose total number of progenies are 100. So according to law of segregation, it should be half and half. So for A also it should be 50. For B also it should be 50. For here, because we are taking two together, so if we do half, it will be 25, 25, 25 and 25. Here it is 50 and 50, 50 and 50 individually. Now, suppose our observed phenotypes, when we count, we are getting the result 45, 48, something. Now, this difference in number, what we are expecting and what we are getting, maybe some of the progenies died in embryonic stage, and because of which we are getting this difference. So when they died in the embryonic stage, now our expectation should not be half because some of the progenies died in the embryo stage. So our expectation should not be half then. It should less than half then. We are expecting half because we are expecting that all the progenies survived. But when all the progenies did not survive and some of them died, so now we should reduce our expectation also from half to 1/3. When here it is 1/3, for independent assortment, what we are doing? Half into half, that is 1/4. Then only we are reaching to 25. But because in law of segregation, the ratio reduced to 1/3, we should multiply 1/3 into 1/2, that is 1/6. Therefore, we have to perform law of segregation first and then only independent assortment to tell whether the genes are linked or not. If we get deviation here, we should not perform independent assortment because in that case, we don't know our expected outcome. So if we get no deviation, that means our expectation is correct. When our expectation is correct, then only we can multiply these two for independent assortment. But when the expectation is different, we cannot do this. So we can only perform independent assortment if for law of segregation we get the result no deviation, because no deviation means whatever we expected is correct. For independent assortment we have to use that expectation half into half. But if we get deviation in law of segregation, we should not perform independent assortment because in that case we don't know the expected proportion. So that's why we have to perform law of segregation before law of independent assortment. And then on the basis of law of independent assortment, either we have to accept or we have to reject the hypothesis. Now this is your homework. Capital A small a, capital B small b, crossed with small a, small b small a. These are the number of progenies obtained. Now perform chi-square test and let me know that whether the gene is linked gene or the genes are assorting independently. Do let me know in the comment section. If you found the video informative, please do like, share, subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.